Hi everybody, and welcome to the second lecture here in Psychology and Law. Today, specifically, we're going to talk about research methods within the field of psychology and law. Obviously, all of the stuff that we're going to be talking about is empirically tested and validated, and so I want to make sure that you guys have a very firm understanding of the research process. For those of you who have taken research methods or other research-oriented courses, this is probably going to be somewhat of a review for you. First of all, we're going to talk about the research process. There's different ways that research can be done, right? There's critical thinking or empirical hypothesis testing. Critical thinking is sometimes in social science referred to as more theoretical versus empirical research, even though that's not really super accurate. Critical thinking, though, challenges assumptions. It can make systematic observations, and there is this reliance on empirical evidence still within this this category. Then there's empirical hypothesis testing, and this is a very theory-driven hypothesis with observation-driven hypotheses, right? We have very clear theories or observations that are informing the research process as opposed to just kind of conceptually thinking about the process in the critical thinking category. One of the very, very, very important things that you guys need to know about the research process, specifically with psychology, but really with all social sciences, is that the scientific method is used. I can't stress that enough. Social science research is still scientific research. We use the scientific method just like natural sciences do, chemistry, biology, physics, engineering. We use the scientific method and have quite a bit of rigor to our methods, right? So the scientific method is just a set of research principles and methods that help scientists, them, reach valid conclusions. We use theories, hypotheses, and operational definitions. Now, a theory is an integrated set of principles that explain and predict observed events, right? So we have these principles that we believe are kind of the causal mechanism of these observed events, and we organize them into a theory. We have hypotheses, which are testable propositions that describe a relationship that may exist between events. So we might have a theory that, this is a very basic example, but we might have a theory that studying for a test makes your grade higher, right? And so we test the hypothesis. The hypothesis is essentially that same theory, right? It's studying will yield higher test scores, not studying will yield lower test scores, right? So it's a way that theory is kind of used and a testable proposition. Then we have an operational definition, right? And these are concrete definitions of a research variable in terms of the procedures needed to control and measure that variable. If I were to just say studying yields higher test scores, that is probably not always true. And even probabilistically, a lot of people say they study, but just because you're sitting in a library doesn't mean you're actually studying, right? And so people say, like, oh my gosh, I pulled an all-nighter last night in the library, but, you know, for 6 of the 7 hours they were in the library, they were watching Netflix. That would not be actually studying. So we have to have an operational definition of what we mean by studying. Studying means actually reviewing the text, reviewing your notes, and actually working toward bettering yourself for that exam that's taking place. And so we have to make sure that those operational definitions are there. And this area of operational definitions is where a lot of social science research tends to slip away and fall away, is that with no clear operational definition, it's way open to interpretation as to what the concept even means. We're going to look again at the research process. We see it's very cyclical here, right? We start with this theory, we move to a hypothesis, we test that hypothesis with empirical research, and then maybe there's some revisions to the theory that need to be made that we restate in that theory. And round and around and around we go. You'll see this later on slides also, but you need to remember that the entire research process is cyclical like this. You might jump in just at the hypothesis section with no theory, and as you do research and revision, you start to develop a theory from those hypotheses. Or you might jump in at, I'm just going to test something just to see what's there, revise it, formulate the theory, and then test hypotheses after that. There are a lot of different goals of science, and if you notice here, I don't differentiate between social science or any other kind of science, right? They're just goals of science, period. And what we do in social science is just science, right? We might try and describe something, right? Do descriptive research. And this might be stuff like, you know, how many homicides are there in St. Augustine on any given year, right? And crime rates are just basic descriptions, right? Then there might be prediction scientific studies, right? Where we might try and say, we think that people in these certain areas are going to commit more crime because of these things. And then let's test it over time. If there are areas that, if we think that poor areas commit more crime than wealthy areas, we can test that by comparing poor areas to wealthy areas over time and their crime rates. And then there's also understanding, right? So instead of predicting crime, we're trying to understand why is it that people committed crime after the fact, right? You are a criminal. Why are you a criminal? Let's try to understand your motivations for committing that crime. In hypothesis testing, there's a lot of different methods that are used. There are observational studies, correlational studies, and experimental studies. Observational studies are just describing the phenomenon in question, right? I'm going to observe people in the library. Going back to that example of studying the library, I'm going to observe people in the library and describe what their study habits are. Then there are correlational studies, and those predict the relationship between X and Y. Do X and Y have kind of a strong relationship to one another, even if one doesn't cause the other? And then the strongest of all of these studies are experimental studies, and this determines if X actually causes Y to happen. And that's a huge distinction between correlational studies and experimental studies. X and Y might be related to each other based on some other factor or some other variable, right? My electric bill right now over the summer is significantly higher than it was in December and January, right? And so should I say that my electric bill is causing it to be hotter outside? Probably not, right? Probably the heat outside is correlated with the months of the year. Summer months are hotter than winter months, and my electric bill is higher because I have to run my air conditioning more, right? An experimental study would determine that X, my electric bill, is not actually causing Y, the temperature outside, right? That actually probably the temperature outside is causing my electric bill to be higher. So we can do that with experimental studies. One of the super important things here is people always say, and it's a true statement, and we'll talk about it in a couple slides, that correlation does not equal causation, and that is very, very true. In experimental studies, though, X is the cause of Y, at least probabilistically in experimental studies, and it's important to know that distinction. So, breaking down observational studies more, observational studies are a systematic examination of behavior in certain people and potentially under certain conditions. So there could be participant observation, it could be archival analysis of looking at newspaper articles or something else, where we're just looking at things that happen. Now, there are some advantages to this, but such as, right, there's advantages like, we can, if I wanted to see how Flagler College students are studying, it's probably best to just go to the library and do an observational study. But there are some pretty serious shortcomings here, right? Some behaviors are more frequent than other behaviors, right? So if we're observing stuff, I might find more people at the library that are there to wind down because there's Wi-Fi there, and that's why they're watching Netflix as opposed to studying, but they've been studying in their room all day. It's also limited to specific groups, settings, and behaviors. I couldn't go into the library and watch Flagler College students study and then say, I know how all college students across America study, right? I can only limit it to Flagler students, and even then, only limit it to Flagler students who choose to study in the library. I imagine a lot of you who are taking this class online are not going to drive to the library to study if you're even in the state of Florida right now. Also, observational studies are very, very, very messy. For field research, you need about 4 hours of note-taking, not taking, that should say note-taking, for every 1 hour in the field, right? And so if I'm sitting there in the library for 5 hours watching people study, I'm probably taking notes for about 20 hours once I leave to make sure I remember every little detail that I saw. And so it's actually a lot of work. People have this idea that, I can just go stand around and watch people and do, hash marks or something next to different behaviors I see, and then I'm done, but it's really actually significantly more complicated than that. Then there are correlational studies, and these are a systematic examination of two variables to see the extent to which these variables are actually related to each other. Now, this varies in direction between positive and negative, and in strength between 0 and 1. And you can see on this chart here that we start off with a negative correlation. So as x increases, y decreases. And 1 is a perfectly straight line, or negative 1 is a perfectly straight line. As we move closer and you start seeing the 0.5s, the 0.4s, and 0.3s, you see there's kind of a general-ish ish trend, but it's a pretty wide, messy trend that's not a straight line at all. 0.2, 0.1, and 0, there's just nothing going on at all. If you were to have to draw a line to describe the data, you couldn't draw a line because it's just kind of a blob. And then, as, again, positive relationships start picking up more, 0.3, 0.4, 0.5, 0.6, 0.7, you start seeing the data start to form a perfectly straight line again until it finally gets up to a 1. A correlation of 1 very rarely actually happens. Now, there are certain ways that you guys need to think of correlations, right? And specifically positive and negative correlations, right? Positive correlations mean that the direction is the same for everything, right? And so as temperature rises, ice cream sales increase. As temperature decreases, ice cream sales decrease, right? They are the same direction. As X increases, Y increases. As X decreases, Y decreases, right? No relationship means temperature does not vary as a function of the day of the week, right? There's just no relationship between the two. It's not like Mondays are cooler than Tuesdays and Tuesdays are cooler than Wednesdays, right? There's just no real relationship between temperature and the day of the week. Then a negative relationship is when as one increases, the other decreases, or vice versa, right? So as temperature rises, people wear less clothing. As temperature decreases, people wear more clothing, right? Now, you guys don't know because we live in Florida, but there's actually these things called seasons, like, winter and autumn and spring, where the temperature actually changes. It's not just hot all the time. But maybe if you guys ever go out of state, you guys will experience that. Some possible reasons why a correlation exists. It could be that X is causing Y, right? It could be that Y is causing X. There could be this third variable of Z that's actually influencing both variables X and Y and the cause of both variables X and Y, right? So if we talked about, we talked about this example earlier of my electric bill, the temperature outside and the month of the year. It could be, right, that my electric bill is causing the temperature outside as well as the month of the year. It could be that the temperature outside is causing my electric bill or the month of the year, or both, right? It could be that the month of the year is causing the temperature outside and causing my electric bill to be what it is. There's a lot of different things. In correlations, we have no causation, right? And so we don't know what is influencing what. We just know these variables are at least related to each other. In big capital letters with exclamation points, correlation does not mean or does not equal causation. Just because two things are correlated does not mean one thing is causing the other. And here are, 4 or 5 things that if you just Google real quick, you'll see that these things are correlated to each other, but actually probably in no way related to each other, right? Like housework cuts breast cancer risk, right? Does this mean that everyone should do more housework if they want to avoid breast cancer? Probably not. Intelligent children are more likely to become vegetarians. Is there something highly intelligent about being a vegetarian? I honestly don't think so because I love a good steak. Fear of hell makes us richer. Probably not. Wearing a helmet puts cyclists at risks. The more likely you are to wear a helmet, the more likely you are to get hit by a car. That could be, or the more likely you wear a helmet, the more likely you are to actually be on a bike, whereas I never wear a helmet, but that's because you're not going to ever find me on a bike because I don't like to accidentally exercise. Also, sex cuts public speaking stress. So the implication of that is have sex before you have to speak publicly, and you won't be stressed out about it. That's probably not the case at all, right? And so while all of these things are actually correlated to each other, it doesn't mean that there's any sort of causal variation here at all, right? In experimental studies, this is the strongest, most robust kind of method that we can use. And this is a systematic observation of whether or not a particular factor causes a particular effect by having a researcher manipulate one variable at a time and randomly assigning participants to conditions. So that's a big, heavy definition, but it's super important that you guys understand this, right? We're looking if one particular factor causes a very particular effect by having one variable manipulated and randomly assigning participants to those conditions. Now, there's 2 variables, right? An independent variable and a dependent variable. And you've learned about these probably since like 3rd grade or something, right? And so I won't spend a lot of time on this, but an independent variable is basically a cause. The dependent variable is basically the effect, right? So the independent variable is what is manipulated. The dependent variable is what is being measured, right? And so make sure you know the difference between those two. The variable type will definitely be an exam question. So in a classic experimental design, there's a control group and a comparison group, or the experimental group and the control group. right? And so in an experimental group, this is any condition of an experiment in which participants are exposed to an independent variable. So let's just say, again, we wanted to see if students who studied got higher test scores or not. We wanted to do an experiment. We would randomly assign maybe 10 students into the study group where we forced them to study. They had tutors that came in and gave study lessons. The control group just sat around and watched Netflix, right? The control group was the condition of the experiment in which participants get what is normal, right? And so there's no real treatment, there's no real manipulation there, right? Then there's random assignment. What's super important is that random assignment takes place, right? That controls for, it should at least control for things like intelligence differences, gender differences, racial differences, educational background differences. All of those things should be controlled for with random assignment because there's no rhyme or reason as to who's assigned to what group, so you can't say that there's some sort of issue or confounding variable. Without random assignment, we call this a quasi-experimental design. And there are times where we have to use a quasi-experimental design. There's no way around it, right? If I wanted to study gang membership and the effect of gang membership on violent victimization, for example, which is a fairly popular topic to study, I can't randomly assign people to be gang members, right? It would be weird if I said you have to be a gang member and you cannot be a gang member, right? It would actually even be highly unethical for me to force someone into gang membership. And so we have to use quasi-experimental design where we say, okay, there's not random assignment, but everything else we'll do our best to try and keep equal. One of the bonuses of causal inference, one of the bonuses of experimental studies is that causal inference is possible. And this is hugely important, right? This is why we do experimental studies as opposed to correlational studies. So we can make causal inferences, right? Experimental studies are very high in internal validity because you control the environment and manipulated certain variables. And because of that, you can make these causal statements. We know because of this experimental study that X, at least to a degree, causes Y, right? And we can see the extent to which that causal effect is there looking at the effect size, or typically R squared values of like regressions. Some shortcomings, though, of experimental studies are they're pretty low in generalizability or external validity. And this is because you control the environment so much, you can't really make generalizations without replications across people, situations, and stimuli, right? One of the things as a trial consultant, which I do outside of here, is attorneys will say to me all the time, and we talked about this even in the first lecture, they'll say, oh, I don't care what your study is, you did it with a bunch of college kids in a lab, and there was only one little thing that changed. That's not how a real case would actually be argued or won. And it's like, well, I understand that, but we needed to have this high internal validity so we could make causal statements. But regardless, it is not necessarily, experimental studies are not necessarily super generalizable, right? Issues in psychology and law research, right? There are some limitations to it. One of them is the experimenter effects, right? For example, race effects in jury decision-making studies are very, very heavily dependent on the experimenter, right? And so if the experimenter is not using a double-blind approach, they can actually influence the outcome of the study, right? If I were to do a study on race effects in jury decision-making here at Flagler, we're a predominantly white campus. I might only have 3 or 4 black people to even compare to the rest of the people in the study. And that could be a problem, right? And so there's some experimenter effects there. There's also replicating social settings. It's really, really hard in a lab setting without a real police officer and a real criminal to, or a real eyewitness even to a crime, to replicate the interactions between police officers and an eyewitness, right? There's also deception issues. How can you replicate certain real-world situations in a lab without lying to your participants, which is, potentially an unethical thing to do? How can you do that? Is there a way to actually replicate a false confession? If we know one of the big causes that causes people to confess to crimes they didn't commit is by physically and psychologically torturing them. Is it ethical for us to do that in a laboratory setting? Probably not, right? So how do we replicate that in research? Now, there are some ways that research findings are shared with others. The main way is through literature reviews, right? Reviewing a topic area to determine commonalities in similar studies. There are special literature reviews called meta-analysis. That's essentially a statistical literature review where you bring together a large number of studies that have all examined the same thing, like eyewitnesses or false confessions, and we combine them all into one big paper that says, here is the state of the field on this topic. And it's typically called a white paper or a meta-analysis, right? There's also experimental articles. And so the discussion of one study or series of studies that attempts to answer one research question is what we use in an experimental article, right? The vast majority of journal articles are experimental articles. Now, for this class, I'm asked to read experimental articles quite heavily, right? And the basic breakdown of these research articles are as follows, right? There's an introduction that basically says, what's the research question? It gives us a big overview of the literature and then tells us what the research question is. There's the method that says, how are you going to study a research question? The results that say, what did you find? And the discussion that says, so what? Right? So how does this fit into the broader context of research? For specifically, you'll see the research question is a testable idea, excuse me, a question that may be investigated or answered by collecting data. It could be a very broad research question, it could be a very narrow research question, but one of the most important things about this research question is that it has to be testable. You cannot sit there and throw out, it would be a very bad research question to say, I believe that angels cause people to commit crime, and then ask people, do you experience warmth in your heart that's indicative of angels? Right? That is not testable. We cannot empirically validate, prove or disprove that as an idea at all, right? An introduction also provides a justification for your research question, right? So you have to couch it in why is your research question important, the background for your question, and so what research has already been done that pertains to your questions to where it makes sense to even ask the question you're asking. And then you should also say what the hypothesis for your question is. What do you expect to find? Based on all this past research, what do you expect to find in this study? And you should be able to do that. The method is what's next. And the methods pretty much say how you're going to study your research question. Basically, after reading a method section, you should be able to replicate the experiment done by the author in exactly the same way. Who were the participants? What were the variables they manipulated? How did they manipulate the variables? What were the dependent variables? How did they measure the dependent variables? What procedures were used? What were the limitations? What issues did they run into? Everything about the research, it's essentially, the method section is essentially just a recipe for how to do the research, right? And so if you want to cook exactly like Bobby Flay does, you follow his recipe. If you want to do the research project exactly like someone else does, you follow the recipe or the method section of the study. The results are, what did you find? This section will reveal what kind of statistical tests the author used to test the research question, and then what the results of those tests were. Please, please, please do not be intimidated by this section, right? You don't need to know the specifics of the tests, but rather you should be able to describe the overall picture of those tests, right? What were the results broadly, right? I'm never going to ask you what the p-value was, what the F statistic was, what the effect size was in the research, right? Just read that to say what were the words in the research or in the results section rather than what were the numbers in the results section. The last section is the discussion section. How does this project fit in the broader context of research? In this section, authors will discuss what they found, how it relates to the literature discussed in the introduction, and then any limitations to the study, implications for policy, and directions for future research. All right? And so this discussion kind of, if you don't understand the results fully, if you read the discussion, it should help clarify a lot because there are no numbers necessarily in the discussion, or at least typically there's not. So in reading journal articles, which is what you're going to be doing in this class, the easiest thing about science is that it's circular. Remember, we talked about that way at the beginning of the lecture, right? We will never actually know the truth. We only kind of get closer and closer to the truth, right? It's imagine vultures circling but never actually going down to the dead animal. That's kind of what we're doing in science, right? Old questions always lead to new questions, and you'll discover, and this is very, very true if you ask any professor here, the more we know, the more we don't know. And so the deeper we dive into the rabbit hole of our careers, the more we realize we don't know that much about what it is we claim to know a lot about, right? If you were to ask Dr. Splain about psychology, she would say, yeah, I know a lot about neuroscience, but there's more about neuroscience I don't know than what I do know. I feel the same way about criminology. I'm sure Dr. McGinley feels the same way about science. I'm sure Dr. Cole over in sports management feels the same way about hospitality, right? Each study is just a building block in the overall picture of what it is we want to know, even though we'll never actually get to that point. And finally, how you should find research articles for your term paper. The great part about summer class is that there is no term paper, right? It's too quick of a time period for me to expect you guys to write a good, coherent term paper, and so I'm not going to set you guys up to fail. The discussion posts are what are going to take the place of the term paper. So for this slide, you don't need to worry about any of the information here on this slide at all. For those of you who take classes in the future, though, this is some good information for you to use. So again, as always, if y'all have any questions, please let me know, and I will see you guys next time.